Welcome back. We'll continue right where we left off. Remember when we were talking about this slide, I said that incoming events are processed by handlers? Well, I didn't really tell you what incoming events are. And I also promised you way before in the second slide that I'll be talking in more detail about port types. And these two things are actually related. So what is a port type really? Now, a port type basically simply defines events that might pass through it. And it also defines the direction in which they may pass. And the possible directions are indications and requests. However, on their own, those two words don't actually mean anything. You need to put a port on a component first so you can judge whether or not events will be incoming or outgoing. Let's say port P is in required position on a component. Then its indications will be incoming events, and its requests will be outgoing events. And conversely, if we have a port P in provided location on a component, right, that's on top in our model, then its requests will be incoming events, and its indications will be outgoing events. All right. So one way to think about this is, if a component is providing the service of a port, right, then other components make requests to it. All right, so requests are incoming, and it responds with indications. Right? That's another way to think about it. And if a component requires a service, then it makes requests to other people, right, to other components. So requests are outgoing, and it gets back indications with the answer to its requests. Right? That is a mental model. It's not necessarily what is true for every component, but it's a way to remember how this works. All right. And now that we've defined this, we can very clearly say what the type semantics of Compics are, because events must be triggered. That is our word for sending in message terms. Okay, events are triggered, and they're only triggered in outgoing direction. And conversely, handlers must be subscribed to a port that passes incoming events of its type or the types it matches. All right? Trigger, outgoing, subscribe, incoming. And now that we have that, we can build these kind of large hierarchies of components that are connected via their ports, with always a higher level component requiring, for example, here a broadcast port, and connecting to a component that actually implements a broadcast abstraction, like this broadcasting component. And this one in turn will require a network, and the network might be provided, for example, by a netty. And as I said before, we can have multiple channels subscribed. So you can see here, there's another channel also going to the network because our failure detector also needs network access. Now that you know this, we can go back to the Zeppelin environment and write a much more complicated Compics example, and we'll use the ping-pong application for showing ports and connections and all these things that we just discussed. So back again in the Zeppelin environment, I created a new notebook for the ping-pong example. You can see here's the tutorial example, which we wrote before, and this is the new ping-pong one. And I copy-pasted the imports over from the tutorial from the Hello World. We're just going to get them into scope now, and then then we can forget about this. They will be in scope for all the other blocks that we're doing afterwards. Okay, so as I said before, we want to do a ping pong example now. And the first thing we're going to need is we're going to have to find the events that we want to pass and we have to define the port type that passes these events. And the events are pretty straightforward. So it's going to be two case classes, one ping and one pong. And also it's not quite as boring. We'll also add into each of these ID number to differentiate the different instances that we have in our system. And notice the class KompicsEvent. This is a marker trait for all events that can be passed on ports and Kompics. And as you might notice, we haven't imported it yet. It's again one of the things that come from Java. So we just go up here again and we imported that one as well. And now we have the case classes, and now we can define a port type that is supposed to pass these case classes. And a port type in the Scala version is an object, because port types are, well, there's only one of them, they're singletons, since they are more like classes, and the ports are actually their instances. We'll name this one, very obviously, ping pong port. And port types have to extend the port. And it doesn't matter so much which direction which of our ping pong goes, just depends on how we want to connect a component. So let's just say we call pings requests. Basically, they ask for a pong. So pings are requests, and pongs are indications, right? They go the other way. So that every component that provides the ping pong service basically answers every ping it gets with a pong. Now we have that. Alright, and now we're also going to need two components that actually send and answer the pings and pongs. The first component is we're going to call it pinger, and it will just send a number of pings and wait for pong replies. As before, pinger is going to be a class that extends component definition. And this time we'll actually need to define a port, and a port is simply a field on our class. So we call it PPP for ping pong port. And the pinger is supposed to require the ping pong port, right? Because it's supposed to send out pings and expect pongs. So that means it has to be a required port on this side. And now that we have that, we can write the two handlers that we need. First of all, we need a handler that starts sending pings. And this one, like before, will be subscribed to the control port and listen to the start event. So write control, upon event, get a start event, and when we get that, we just send the first ping. And to send events, we trigger them. So we want to trigger a ping with ID 0 on the ping pong port. All right. And then the second handler, we want to react to incoming pongs by sending a new ping with a higher ID. And to do that, we subscribe to the ping pong port, again upon event. And now the case we're looking for is the one where we're getting a pong with some number. And then we handle that by printing something, so we can actually see that something's happening. And secondly, with answering with another ping, with an ID one number higher. Alright, this would be perfectly fine for the pinger. However, remember that I said that we didn't want to execute forever, so that we actually get some feedback from Zeppelin. Now, that means that we have to decide some way to stop, and the easiest way to do that is simply by picking some arbitrary number of pings and pongs when it send back and forth, let's say 10. So when we get to 10, we just shut down, like we did before. Alright, that's the pinger. Now we're going to do something very similar with the ponger. Again, we define a class. Again, we need the ping pong port. Just this time, we want it the other way around. We don't want it to be a required port, we want it to be a provided port. And this time we also only need a single handler, which very simply answers every ping it gets with a pong. Because our pinger decides when to end the experiments, so we don't have to do any bookkeeping here on the IDs. Just so that we can see something fun, we'll also go and print the current number that we got as a ping. So when we subscribe again to the ping pong port, in the case that we get a ping with some number, then we handle that by first printing and then simply answering with a pong of the same number on the ping pong port. Okay, now before we can run this like last time, there's one more thing we have to do. For last time, we didn't really have to connect anything or do any setup because we didn't use any custom ports. In this case, we defined a new port, and we need to connect our two components with channels so that they can actually communicate their ping and pongs. And the way we do this is that we define a parent level component that creates instances of our two ping and ponger components and also connects them. So the parent level component, let's call it ping service. And again, it's just a normal component definition. It doesn't need any custom ports this time, but it needs custom components. So we define two values, for the one for the pinger. And we have to pass a second field here, which tells the system whether or not the pinger component actually requires some setup parameters to be started. And since it doesn't, we didn't configure it with anything, we simply pass init none. And I spelled out the full name. I could have imported it here as well. Just there's a tiny name clash there in the API, which I didn't want to resolve now. So this is the easiest way to do it for now. And we do the same thing for the ponger. So ponger C, and again, no init parameters. Now I've created these instances, and now we have to connect them. And that's fairly straightforward. We simply say connect. We tell it the port that we want to use for the connection, because remember, components can have many ports, so we have, whenever we want to connect them, we have to tell which ports are supposed to be used. So in this case, it has to be the ping pong port. And then we want to connect the ponger to the pinger in this direction. So the arrow has to go from the provider to the component that uses the service. All right, and that's the ping service. Now we simply have to run the code, and we could technically do the same thing as we did in the tutorial, just run it with Compics create and start. But we need to tell Zeppelin that it's actually supposed to wait until the VM stops. And the way we do that is we simply defined a short custom start command for Zeppelin, which waits until Compics is stopped before it returns from the code. And to use that, we have to import the environment for the course, which is this import. And then we simply write run Compics, which is also much shorter. And we can use the nice way of just writing ping service in the more Scala-y way. And then we can run this. And you see we get our pings. It's the initial ping. And then you can see the back and forth between ping and pong and ping and pong. That finishes the Compics tutorial. This should give you enough knowledge on Compics and its Scala DSL to finish the contents of this course. If you're interested in learning more, feel free to check out Compics documentation at Compics6SE. Here you can find both the documentation for the Java core, which remember you're still using even if we're writing Scala, and more specifically the Scala code. And you can find the not Zeppelin specific but general Compics examples for the Hello World, and also a much larger version of ping pong. So thank you for listening and good luck with the assignments.